Good morning, students. Today we have arrived to the last topic of the given chapter, number 5, complex numbers and quadratic equations. And by looking at the topic, you are very much familiar with this topic because you have already read in class 10th standard. And you must be remembering about the nature of roots. That was the last topic, nature of roots of the given equation. And based on the value of discriminant, you used to analyze whether the given equations will be having or distinct roots or real roots, equal roots or non-real roots. That is completely dependent upon the discriminant value d. And then you try to use based on the types of roots the formula of quadratic equation, that is quadratic formula. So let's understand what is there in class 11th. You arrived at a situation where the value of d was less than 0, and then you called it was a non-real roots, or we can call it, in other words, imaginary roots. So let us consider an equation which is a quadratic equation, px squared plus qx plus r equals to 0 with real coefficients p, q and r, and p not equal to 0. Now let us assume that the discriminant d is less than 0. That means the value of d is b squared minus 4ac, which is also less than 0. The solution of above quadratic equation will be in the form of complex numbers, which is given by x equals to minus b plus minus a square root of b squared minus 4ac by 2a. And here this is for distinct and real roots, and this is for imaginary roots, which is minus b plus minus I square root of 4ac minus b squared by 2a. This is the way we find it out, the roots of a complex numbers. Complex quadratic. A quadratic equation which has got imaginary roots. So on the basis of d, find the value of d as b squared minus 4ac, and depending upon that, if d is less than 0, we go by the formula minus b plus minus I square root of 4ac minus b squared by 2a. Remember, a polynomial equation has at least one root. And if it has got n degrees, then it will be having n roots. Going forward with the examples, find the roots of equation x squared plus 2 equals to 0. So how the solution will be? First of all, we'll find the value of d, which is b squared minus 4ac. Here, this particular equation is not in a standard form. So first of all, we'll write x squared plus 0x plus 2 equals to 0. So b is 0 here, so 0 squared is 0 only, minus 4ac, 4 into a into c. 0 minus 8, which is minus 8. Right? Or simply we can write here x squared plus 2 equals to 0, so x squared equals to minus 2. Or x equals to plus minus a square root of minus 2. As we know that a square root of minus 1 is iota, which is I. So simply we can write plus minus a square root of 2i. Right? So this is the solution of the given equation x squared plus 2 equal to 0, which has two solutions here, as the degree is 2, as we have seen in the note section. If the degree is n, the solution will be n. So plus root 2i and minus root 2i will be the two solutions of the given equation. Next one. Solve square root of 5x squared plus x plus square root of 5 equals to 0. So finding the discriminant here, d equals to b squared minus 4ac, which is equals to 1 minus 4 multiplied by square root of 5 into square root of 5, which is a value, the coefficient of x squared, and the coefficient, that is the constant term, which is square root of 5 only. So the result will be minus 19. That becomes d is less than 0. So we place the value in the given equation, x equals to minus 1 plus minus a square root of minus 19 upon 2 root 5. Right? So this becomes minus 1 plus minus 19i to root 5. So here again we have got two values of x. One is x equals to minus 1 by 2 plus 19i by 2 root 5 here. This is the first one. And second one will be x equals to minus 1 minus 19i upon 2 root 5. Right? That is 2a. Here will be 2a. Okay. So 2 root 5. So that is all from today's class. You can solve more problems on quadratic equations. And for any problem, you can ask in the virtual classroom. Thank you.